Welcome back, guys, to this video. We are going to build a complete production-ready AWS network architecture from scratch, step by step, piece by piece. And I'm going to show you exactly how traffic flows through each component. On the screen is the architecture that we are going to build. By the end of the video, you'll understand how VPCs isolate your network and why we split subnet into public and private subnets. So follow along and enjoy. Welcome. Okay, guys, let's start. And once you log into the console, this is how the homepage looks like. So you just search the VPC, yeah, and click on that to start. Then you pick the option to create VPC, and we will go with the VPC only option. You give your VPC a name. So mine, I'll call it my production VPC. I will leave this as the default manual input. Then here we will input our CIDR block /16 10.0.0.0/16. We leave this as is. The default, the tenancy will leave it as default. And yeah, it has automatically created a tag with the name and the value. The key is name and the value is my production. Okay, I've seen this. Let me correct that here. My production VPC, that should be okay. Then you press, that's just about it, confirm everything is okay. Then you create your VPC and give it some time to create. Then you get this success message that your VPC is created. Our second step will be to create the internet gateway and then attach it to this VPC. So on our left here, we have the different options when you're working with the VPC. So what I'll do, I'll just come here to internet gateway, pick that, and then create internet gateway. Then I'll give it a name. So I'll call it my VPC. Let's go GW. Okay, same, it just creates a tag with the key and the value being the name of the VPC. So we create, and that's it. You see a success message. The VPC has been created and it's now able to communicate with the internet. So the VPC resources in this VPC can communicate with the internet. Then the next step is to attach this internet gateway that we've created to the VPC. You can either use this option here on the message, but the recommended use, you come here to your actions and pick attach to VPC. Then you select your VPC. If you have many VPCs, then they will appear here. Then you will pick the relevant one. For me, I only have one custom VPC, so I'll pick that. And there you go. You attach it, and it's already attached to our VPC. Okay. Our next step will be to create subnets. So we will be creating subnets on different availability zones. This is because we are designing for high availability. So we will have resources on both subnets just for redundancy purposes. We will have public subnets and private subnets. So we'll come here to the left and click on subnets. So we will create public subnets for resources that can be accessed from the internet and private subnets for the application server, which we don't need it to be accessed from the internet. So we come here to subnets, then we create subnet. So we will pick the VPC. You first pick the VPC where your subnets will sit. So we will pick this one, the one that we've just created. And then you see, we can only assign IPs that are within this block. So we will start with the first public subnet. We will call it public. This is now in the first AZ, public underscore subnet, then AZ1. This is our first AZ. Just for predictability, I'll pick US East 1A. Then I'll now, okay, this is the like the parent CIDR block, but now I'll pick specifically for this subnet. So I'll use 10.0.1.0/24/24 here, and then I'll create a second subnet. Now this one was the public subnet. So I'll come here and create now the private subnet in this AZ. So the AZ is the same, but one is a public subnet, the other one is a private subnet. So Once our subnets have created, we proceed to enable auto-assign feature on public subnets. This is to ensure resources deployed in the public subnets are automatically assigned a public IP for internet communication. As you can see, it is disabled. So we go to actions on a subnet, and then you'll see the auto-assign IP setting feature. Then that's where we enable it. So you just enable, and then you save. And you can see the success message now. Our next step is to create the route tables. This is to ensure that traffic is directed to its intended destination. So we'll come here to the route tables, and we will start with the public route table now, which will be used for traffic that is intended for the internet. So you just come here, route table, then create route table, then you give it a name. So I'll give it a public underscore route table. Then we select the VPC, which is our custom VPC, and that's just it. And then you click create. Then our route table was successfully created here. Okay, then the next step will be for this route table. Since it's the one that is responsible for traffic that is intended for the internet, we will associate it with the public subnets. So we will create a rule or a route to the internet. So you come here to edit routes. You edit routes. Then you see there's already a default local route that is automatic here, and you cannot delete this route. So this is ensures that resources within a VPC can communicate with each other. There's traffic flow within the VPC, so we will add a route to direct all other traffic to the internet. So our route will be to the internet, which will be this one here, and then it will go to our internet gateway. So you pick on these drop downs, you see you can direct traffic anywhere. So we pick internet gateway, and then we pick our internet gateway, the one that we created earlier. So that we will have the two routes in our route table for the local traffic, and then for any other traffic towards the internet. Then you just save your changes, and as you can see down here, these are our routes. So we have created the routes. So come here. So this is the right, click here, subnet associations. Then we will associate it with the public, these two public subnets. So you come here, you edit here, edit subnet associations. Then you click this, you pick this and this, and then we save the associations. So as you can see, now you can see here, they're now, no, not this one's here. They are now associated with this route table, explicit, you see, too. Okay. Now that we have the public route table, we will create private route tables. For our private subnets, they will not be interfacing with the internet in any case, but they'll go through the NAT gateway. And since it's advisable to deploy NAT gateways in each availability zones for redundancy, so we will have two private route tables, one pointing traffic to each of the NAT gateways. So we will just come back here to our route tables, and then we'll create a route table. So we'll create for the first AZ, we'll call it private then we just say AZ1. Then the same, just select our production VPC. Then come back here and create another route table. So now in this time it will be for AZ2. Same VPC and create the route table. So if you come to our route tables, you can see we now have three. This is the public route table, private route table AZ1 and AZ2. This one has already been associated because we have associated the two subnets, the two public subnets, but these ones are not yet associated. So we'll leave this for now. We'll not associate them until we have created the NAT gateways. Is to create the security groups. Security group acts as firewall on the subnet level. They restrict, this is where you restrict what kind of traffic will be allowed in or out of the subnet and into the resources in the subnet. So on our left, you see security, then you click on security groups. That's where you create, then it will open that page. Then you go to create security group. And we will start with the first security group, which is the web server security group. This is to will allow HTTP and HTTPS traffic from the internet into the public subnets. So you give it a name. Ours will be web server security group. Then the description, which is to allow HTTP and HTTPS traffic into our subnet from the internet, from anywhere in the internet. Then now we add inbound rules. Now these are we specify the ports, the kind of traffic that will be allowed. So the first is HTTP, and the source will be from the internet, any IPv4 and traffic from the internet. We leave the description as optional, then add the second rule, which is now to allow HTTPS from anywhere in the internet. Then there's always a default outbound rule that allows all traffic to leave the subnet towards the internet, and we will leave that as is. Then you click create security group, and it will be created. As you can see, we have a success message. Then down there you can see the inbound rules, the ones that we have just created to allow HTTPS and HTTP. Then for the outbound rules, you see we have the default, which allows all traffic to leave the subnet. Then we will proceed to create the second security group. Now this will be the one for the private subnet. We will call it App Server Security Group. This security group will allow traffic only from the web server, that is from the public subnet into the private subnet. So we'll give it a description, and that is to allow traffic from the web server. So this security group will be associated with the private subnet. We pick our VPC and then we add rule. So the first rule, we will only allow custom TCP, that is application traffic from the web server towards the app server. So this is a custom. The port that we set up in our application is 8080. Then we will pick custom and then specify the web server security group, just the one that we created. We will specify that you pick. And then the next will be to allow SSH again, so that we can be able to remember the web server is acting as a bastion host for to the app server. So we'll allow SSH from the same security group, SSH traffic, so that we can remotely access that. Then the third will be ICMP traffic, so that we can be able to ping. One of the tests that we'll be doing is to see if we can reach the app server from the web server. So we allow ICMP traffic for pinging, and then we specify again from the web server security group. As previously discussed, we have the default outbound rule, which we will leave it as is. And a point of correction, I will change the source of the ICMP traffic to our local network, which is 10.0.0/16, so that we can be able to ping the app server from anywhere in the network, not necessarily from the web server alone, but from any other resource in our local network. Then we create the security group, and it's created, as you can see. Look, confirm from the outbound rules that we have all the necessary rules to allow the necessary traffic, and then confirm also the outbound. As you can see, all is okay. Let's now create the NAT gateways, which now will be connected to our private subnets to allow for the resources in the private subnet to access the internet. The use case is when you need the resources to maybe fetch updates from the internet, but these resources cannot directly be queried from the internet. So on our left, we come here. The first thing we need to do is to allocate elastic IPs. These are like static IPs that we will use to these are static IPs that we will attach to our NAT gateways for predictability, so that we know what they are. So we come here and allocate static IP, and then you pick from, you're going to pick from Amazon pool of IP address. The network group, will just leave it as is, as a default. Then you can add a tag here, and our key will be name, and the value is NAT gateway. Easy one. So I will just launch one NAT gateway for one easy, but for redundancy again, you just launch another NAT gateway like this, and then you associate it with your second availability zone. So then you come here and click allocate. So we have our elastic IP, which has been allocated successfully. We will then proceed to create the NAT gateway now. So we come here, NAT gateway. We'll create one NAT gateway in AZ1. So come here, create NAT gateway, and then we will put it in. Let's give it a name. Can call it NAT gateway AZ1. Then we select, now we put it in our public subnet AZ1 here, and then we leave it as public. Then we allocate the elastic IP that we had just created here, and then we can leave the rest as they are, and then create NAT gateway. So we have to wait until this state here changes to available. Once this changes to available, then we will proceed with the next steps. Now you see our NAT gateway is available. So remember the route table we had created, the private route table that we had not associated with any subnet. So we need to create routes so that this route table can direct traffic from the resources in the private subnet to the NAT gateway, which will then communicate with the internet gateway, and the traffic will go to the internet. So we come here, you edit routes, then you add a route. So this route will be, so the target will be the here destination to the internet, and then the target will be to our NAT gateway. Through our NAT gateway, then we pick now our NAT gateway, so that now we have two routes, the local route and a route to the internet via the NAT gateway. Then you come here and you save the changes, and there now you can see we have two routes, one through the NAT gateway and a local route. The next step will be to associate the route table with the private subnets. So on the subnet section, you just click on subnet associations, and then you'll see the subnets that are not associated. So you go to edit subnet associations, and then pick the two private subnets, and then save the association. Now these subnets are associated with the route table, and any traffic from these subnets will be directed to the NAT gateway, and then onwards to the internet gateway and into the internet. Now the next step is to launch the EC2 instances so that we can test. So we'll come to our search bar and type EC2, EC2, and here we can find them, EC2. So we're going to launch one EC2 instance in the public subnet and another EC2 instance, which is the app server, in the private subnet. As you can see, we don't have any instance running, so we will start with the first EC2 instance, which will be our web server. I will just do this demonstration using one availability zone, but having in mind that for any production, you will need to achieve redundancy. It's just a replication. It's just a replication of what you do in one AZ, then you do it in another AZ, just for redundancy. So for demonstration purposes, I'll only do on one AZ. So we'll give our instance a name, which will be web server AZ1. Then we will pick this AMI, and then we'll just pick the default, which is T2 micro, because it is free tier eligible, same as this one, the instant type. Then I'll create a new key pair because I do not have one, and since I will be using a Linux, I'll just pick it as a .pem. So I'll give it a name. I'll call it networking lab. Key pair. Then I will download it to my machine and keep it safe. Okay, then I'll create the key pair. Yeah, okay. Okay, then now we come here to network settings, and first we'll have to edit because we have to pick the right VPC. So we pick our VPC here, and then this one, since this is the web server, it sits in the public subnet, we'll put it in public subnet AZ1. You see, auto assign public IP is enabled, so any resource in this network is assigned a public IP, so our web server will have a public IP assigned. Then we'll select, we already have an existing security group, the one we created, the web server security group. So this is what we will pick, web server security group. And then here, I will just input a script that I have created. I will leave the rest as the default, just the way they are. What I'm looking for, sorry, it's not here, here on the advanced detail. I will come all the way down here and put a user data just for the HTML file for what we'll be able to see once we try to access the web server. So once I have everything that I need, I'll just so we have a summary of what of the options I've picked here. I'll just check if I have everything. Yes, I think I have everything I need. So I will launch the instance. You just click here and launch the instance, and then give it time to. And there you go. You see, it has already. If you come back here to our instances, you should be able to see an instance that is launching. So it's still pending state, so we'll give it some time. Then as we wait for that, I'll go ahead and launch the second instance, which is our app server instance. I will just follow the same steps. we use Linux 2023, 32 micro instance type, then keep here what I had already created, and then we select the existing security group, and we need to change. First we change the VPC. VPC. Then now when you select the existing group, it should come here. There you go. Then here I'll also put a user data script, just the same as what we did for the other one. Just a correction. I've remembered I forgot to put it in the correct subnet, but I've just checked. It is in the right subnet, which is our private subnet, is E1. And you can see here, this one, since it's a private subnet, it has this one we didn't put on, so that means it will not have a public IP. So let me check. Just I have everything right, and then I'll launch the instance. And there we have our instance. Let's see if the first instance, the web server is now running, the one that we created. So we will give this time to create. The next step is to do the tests, just to confirm that everything is working okay. So the first step will be to test from our web server to see if we can reach it from the internet, and also we can reach the internet from the web server. So this is our web server, and the details, as you can see, it has a public IP. This is a public IP and also a private IP. So from my machine, I will try to SSH into this instance so that we can confirm that it is reachable from the internet, because I am remote from where the instance is located. So I will first navigate into the folder where I have the key pair. So this is from my machine. Yeah, so I'll SSH into the instance. Then we'll use this public IP. So I need to copy this and then paste it here and see if we can SSH into the instance. Oh, sorry, I put in the wrong. It should be EC2. And there you go. So that means, you see, I can log in by SSH. So that means I can reach it from the internet. So now we are inside this instance, the web server. So let's see if we can ping Google. So we're just testing for DNS resolution and see if we can reach the internet from here. So we'll just ping google.com. There you see, we can reach Google. It's reachable. So if you check this IP here that this command has returned, you should see it corresponds with this one. So that means we can reach this instance from the internet, and from inside this instance we can reach the internet. So let's see if from web server we can reach from the web server. Let's see if we can reach the app server. So we need to come here and get the details of the app server, the private IP. So our app server is here. So you see, our app server does not have a public IP before the address, but we have this one. So this is what we need. So from our web server, we will try and see if we can reach the app server. So we'll do ping then the So we are using the private IP of the web server .2.1.1. And you see, it can reach the web server, so that verifies that there's a connection between our web server and the app server via the security group that we set up, the app server security group. So it's allowing traffic from the web server. Let's now test to see if the app server can be able to reach the internet, and if it's possible to reach the app server from the internet. So what I'll do, I'm already on the web server. So remember, we can't reach the app server directly from the internet. So I will SSH from the web server into the app server, because our web server is acting as also the bastion host to the app server. So first I need to copy the key pair from my local machine to the web server. Then that is the same key pair that we will use to SSH into the app server. Now that I have copied it to the web server, let's now log into the web server. Okay, and there we are logged in. So let's see where we are. Yeah, let's see if we can see the key pair here. Yeah, there we have it. Then now we SSH. So we are going to SSH from the web server into the app server. SSH. Then the private IP. Oh, sorry, we need to change. We need to change the permission on the key pair. Sorry, got that. That should solve our problem. And there you go. See, you see this IP here is similar to what we have here, the 10.0.2.112. So that means we are able to SSH from the web server into the app server. Now let's see if the app server can reach the internet. And as you can see, it's working. So that means from the app server, your traffic can go to the internet. Now we need to confirm which IP the app server is using to reach the internet. Remember, this app server does not have a public IP that is routable to the internet. So it is going via the NAT gateway to the internet. So by using this command, we are able to verify that the IP, the public IP used to reach the internet from the app server is the elastic IP that we allocated to the NAT gateway. As you can see, that is a public IP that is routable to the internet, the elastic IP that we allocated to the NAT gateway. Let's go ahead and verify that that is indeed the elastic IP that is attached to the NAT gateway. And you can see it's the same IP. Yeah, let's compare them side by side. You can see 21.86, which is what we have on the right side. Next is to do a test to see if from the internet we are able to reach the app server. So right now I'm SSH'd into the app server from the web server. So I'll go ahead and exit from the app server into the web server, and again exit into my local machine and do the tests. So the test will be to SSH from my local machine. I will exit again, and now we are on my local machine. So I need to SSH into try to SSH into the app server from my local machine, which is now acting as the internet. I'll use the same key pair and the private IP of the app server. And remember, our app server does not have a public IP. So that is the public IP, the private IP, sorry, the private IP of the app server. And it's trying to establish a connection. So let's give it a few seconds to try that. And as you can see, the connection has timed out. So that means it's unable to reach the apps. We are unable to reach the server from the internet. So that verifies our